In this video, we will see how to create and use a database in a concrete case. So here the concrete case will be, we have a list of books that we want to retrieve, add, delete, edit, what we call a CRUD, create, read, update, and delete. We will start by making a very simple architecture. We will create a dedicated folder specifically for the backend and a separate folder for the front-end development. Here, we will start with the backend and we will directly create the database. We can refer to it as DB Books as a specific example for clarity. And so the DB Books collection will contain several unique items. So here, we can add additional rows to see how it visually looks and improves. Here, we currently possess only an ID, along with a specific date when this row was created. We will include a title, which is a descriptive string, as well as the author's name, which is also represented as a string. I can modify the existing data to include some random values. So I will write anything I can think of, but this will be for testing a bit later on. And in just 15 seconds, our database is already ready to use. Now it's time to create routes. The routes we will define will be the specific URLs we utilize to retrieve, send, delete, and manage data effectively. So we'll start with the simplest route, and this particular route will allow us to effectively retrieve all that data. For example, get books. Once I've created my get books route, the first thing I want to do is change the method. So here I've either get, post, put, or delete. I think the names are quite clear. We'll choose get. And our goal will be to retrieve all the data we've written in the database. I'll demonstrate two methods. I'll show you a straightforward and very simple method. We'll create a new node called dbFind. Here we can choose the table, so DB Books. This returns rows to me. Each row will represent an individual entry or line in the database. So it's a table of rows, and each row corresponds to an item. So this is one item, this is one item, this is one item. I will send this back in the response. We absolutely need to send this in the response because the response is what we can retrieve on the front end. So in terms of interface, and finally, I'm finishing linking the execution thread between the dbFind and up there. So if I execute this and press Control Space to visualize the data, I will see that here we have exactly the same thing. It returns absolutely everything we have in our table. Now, I will show you a slightly more advanced and flexible way to do this. It will involve using db_from and making a query on it. I select my table when using db_from. I have one database, DB Books, for making queries. So I will do a select, and here I can decide which fields I want to return. I only want to return the ID, title, and author. If I pull a thread here, I can do a db execute. And when I run my db.execute and press Control Space, I will get a result that contains the same thing, except that we won't have the variables that don't interest us. I will finish connecting all these blocks. And of course, I will need to return this in the response to make it a bit cleaner. What we can say is that for the response, we expect to have a specific result. What is this specific result? It will be an array of objects, and each object is what? It's an identification number, a title of the work, and an author. We do this to ensure we can easily verify that the correct type of response is returned. So in fact, if, for example, I add another field, I will write anything on it. And if I try to connect my result to my response, I will get an error missing property, because inside, we don't have a property with a similar name. So if I delete this property now, I can connect my result to my response. Now we will do the same, but with create books. So once again, a new root first reflex check the method. The method is correct. To successfully create a new entry in the system, we use the post method, and we will need to change something. When we want to add a new book to our database system, we should have two input fields on the front-end interface, one specifically for entering the book title and another for the author's name. And these inputs on the front end will be sent to the back end so that it knows what data we will use to create this book. And this data corresponds to the body. In the body of the document, we will include a string variable for the title and another string variable for the author's name. Now that I have my body, I can pull a thread here, type db insert. I can choose my table once again, and now my data appears here. And now what I will send in my data is obviously what I have in my body. So with just this part, I can create a new book and send it to my database. We could stop our discussion there for now, but what I truly appreciate is that once I've either created or deleted a book, I want the current state of my database to be accurately returned to me. So for that, I do a dbFind, which is essentially what we did in the ZIT. I select my table again, and I can send that in my response. To do it properly and efficiently, I can easily retrieve the detailed structure of my output directly from GetBooks. I can easily right-click to copy the information here and then successfully paste the exact same content in that location for my response. Now regarding the delete and update processes, they will appear quite similar. So let's proceed with the deletion immediately. We will paste the specific response type here. Here the reflex is to check that we are using the correct method. That's not the case here. So I will select delete. So what are your thoughts on the best way we could go about deleting a specific book? But we will utilize its ID. The identification number is unique and allows us to accurately identify each book. In the application Delete Books, I will carefully pull a specific thread to execute the delete by ID function. I will select my table. And how do we retrieve the ID of the targeted book in the input route? We will include a unique ID in the body of the request. The ID that we will send from the front-end application will be transmitted to the backend server to clearly specify which specific book we wish to delete. So here, you see that I cannot link my body to my ID because it's an object expected input, a string. So what I'm going to do is pull that. And when it's an object, what we can do is get a property. And there, if I click on it, I will be able to select the ID. Once I've done that, I repeat the pattern of what I did in Create Book, which is to do a DB find to return the current state of my database. Now, all I truly need is the update, which is a put in place. This time, we can directly tell it what its response will be. And this time, within the body of the request, it will be identical to what we have in the create method, specifically including the title and the author, along with the unique ID to clearly specify which book we are modifying. Now we simply need to pull a thread here to perform a database update by the specified ID. There, I can easily select my preferred table. Here I will need to put the ID and here the data that I will use to update my field. So what I'm going to do is take my body here. I actually want to do a get properties on all my data. So this corresponds to a spread that will allow me to fully destructure my object to retrieve all its properties. So I put the ID here and update here. Now I can't do that because we expect an object for the upcoming update. My plan is to use create object, and I will create the object with the essential properties of title and author included. What I can do directly is add this specific item and that one, and so I will be able to put these fields here. Now, all that's left to do is perform a DB find operation as we usually do by selecting the Debbie books and then sending the response back here. And now we have set up our entire backend. And in the next episode, we'll see how to connect everything we've done here to our interface.